Good morning or good afternoon, depending on if this is first block or fourth block. First of all, I'd like to apologize that I'm not here. Unfortunately, all of my children decided they would get sick at the same time. Unfortunately, I'm staying home with them today. However, we should not lose a lot of ground today. We should be able to keep moving on. So I'm going to make these videos to show you how to do the rest of the vector lecture help sheet that we started yesterday. So 1 through 3 we got through yesterday, and we'll be doing 4 and 5 here real quick, and then we will get you started on your write your own problem, which will be next in your the next video that you will watch, but that'll be a later video. Okay, so first of all, grab your vector lecture help sheet. And then if you take a look at, we're looking at number 4 here, all right? So what we're gonna do here is we're gonna determine the resultant when we have more than 2 components, okay? Now, what's nice about number 4 is all of these components are set at a cardinal direction, meaning they are perfectly north, east, south, or west, okay? That makes things a little bit simpler. When we go to number 5, one of the components will not be set at a cardinal direction. It will be, at some angle, and so we'll have to do a little bit of extra work there to get that ready. But number 4 is pretty simple for us. So we're going to do A together, and then you'll do B. All right. So A, we've got 15 kilometers north, 5 kilometers south, 10 kilometers east, 5 kilometers west. So we're just gonna go up and then down, then right, and then left. So this one's not too complicated here, but take a look. Here's what A would look like, okay? So we're gonna start here, and we're gonna go up 15 kilometers. So that's 15 kilometers north, but then we are going to immediately turn around and go 5 kilometers south to about here. All right, so that's 5 kilometers right back. Then we're gonna go 10 kilometers east, and then 5 kilometers back. All right, so this is what my component sketch will look like, and my resultant sketch will look, or my resultant will draw in just like that, okay? And so this would be one of the diagrams showing the original components with the resultant. So we've done that, and that's straight off of the lecture help sheet directions. The other is we need to subtotal the components with the resultant. So this math here is pretty simple. You probably in your head have already figured out that we've got a total of 10 up and 5 over, all right? Well, here's the process for when the numbers aren't so nice. How do we do this? What we do is we make a little T-chart, all right? And then on one side, we do the north and south stuff, and on the other side, we do the east and west stuff, okay? So on this side, we're just gonna look at north and south. So just north and south, we go, the first one, we went 15 north. So that is if you remember, north is positive, so we've gone a positive 15 kilometers. Then we went 5 south, south is negative, so we went a negative 5 kilometers. And so if we subtotal that up, we just add those, right? We end up with a positive 10 kilometers. So what I'll do is I'll come down here and I will draw 10 kilometers north. Then I'm gonna look at just my east-west. We go 10 kilometers, that's a positive 10 kilometers to the east. And then we go 5 kilometers back to the west. West is negative. We add those two and we get a positive 5 kilometers. So come down here to my little sketch again. And now I've got 5 kilometers here, and there's my resultant. All right, now, this is no different than anything we've done before. We just need to figure out what the resultant is and that angle and describe it. Okay, so now it is SOHCAHTOA time, all right? And it'd be just 10 squared, or not SOHCAHTOA time, it's gonna be Pythagorean theorem time, excuse me. 10 squared plus 5 squared equals r squared, so that's 100 and 125. The square root of 125 is what r will be, all right? And so I'll write it out. 10 squared plus 5 squared equals r squared. And this is where the calculator comes in. It should be 125. I'll show you. All right, so we're gonna square root that, and we get 11.2 kilometers, and it would be kilometers because we're adding a displacement vector to a displacement vector. All right, now we need to find that angle, just like we did yesterday. We will use our trig functions of SOHCAHTOA. I like tangent because I don't have to round the 5 or the 10 because that is my opposite side, that's my adjacent side. So the inverse tangent of opposite over adjacent will give us theta. All right, so the inverse tangent of 5 over 10 is theta, or 1/2. And so we're gonna second tangent, 5 divided by 10, and we get 26.6. And so then what we need to do is write out our whole thing. Our final displacement would be 11.2 kilometers, 26.6 degrees. And now we have to describe that angle. If you just look at it, that is to the right of north, so that is east of north. Or you could say, I drew north first and east second, so the reverse order would be east of north. All right. Okay, so at this time, what you need to do is you need to pause this video and you need to do 4B on your own. Okay, so hit pause, do 4B, and then unpause, and I will work through 4B for you. Okay, so pause right now. Okay, unpausing.